right? And we talked about why that is. It's because if you think of the way the recursion solves a problem, it's like, hey, I want to do this, I want to do this again, and do this again and again and again until I stop at some point, which basically sounds like a loop, right? And so a for loop obviously could handle a lot of that workload too. However, there are certain problems in which we can only solve with recursion and not with a for loop. And usually those problems fall in the category of if I know how many times I need to do something, like that's great. But what if I don't know how many times I need to do something? And what if not only do I not know, I actually don't even know kind of like what the like it's not just like the number of times I need to do something, but it's like kind of how deep into the iterations I go. And so recursion becomes a really great problem in that case to solve those caliber of problems, because with recursion, the idea is recursion doesn't try to solve everyone's problems all at once from the get-go. It only tries to solve its own problem, right? It does what it can, and then it offloads the rest of the problem to the next iteration of the function. So what are some problems that kind of touch along this idea that we can only solve it with recursion and not with iteration? A lot of it has to do with nested data structures. So we talked already about how an array can hold any data type, including other arrays. And when it does, we call it a nested array. As in, there's more than one array level depth into it, right? So even in this crazy array here, even though it looks like there's 9 elements in it, in fact, in the outermost array, there's only 2 elements. There's a number 1, which is a number, and then there's the second element, which is an array holding 5 or 6 or 7 more arrays, but it's still just considered one element. And so if I was to say, can you write me a function that actually goes through this array and prints out every number in there? One, it's a very fair ask, right? Like a lot of times if I look at an object or an array, it may be really heavily nested, and I do want to know every single thing that's in there. Having said that though, the downside of that really then is say, okay, well great, how does my function do that? And notice how in this case, it's really not, it's possible, but it's not practical for us to write a for loop, right? If we write a for loop that prints out every single array, so for example, if this is how we traditionally print out an array, I give you a one-dimensional array, you make a for loop, you start the I as 0, you go through the array.length, and for every element, you console log out element, right? This, if the array was just 3 numbers or 1 level deep, it prints out exactly what we want it to print out. But if we feed it in the array that we saw earlier, where one of the levels is nested, well, then the printout becomes 1, and then rather than printing out 2 and then printing out 3, as far as this function is concerned, 2, 3, that's one array, that's one element, so here you go, right? And this does not do what we want to do, which is print out every single element on its own row or kind of by itself. So how do we actually then solve this problem? Well, if we want it to be a little bit more if we don't want, if we say, for example, that well, it's only 2 levels deep, and I know for a fact that we can get there. Well, the short answer is great. So then, if we print out this array and we modify our existing logs in array function, right? We can just do a if-else check, right? If the element is an array, we do one thing. Otherwise, we do something else, right? So the way that this problem is set up here now is notice how here we are in fact using recursion, right? Because we're calling the logs in array function within the logs array function, right? But notice how this doesn't mean we can't use a for loop. In fact, it doesn't mean that we can't use any of the tools that we've already learned, right? The problem here, and the reason why we're using recursion really is between lines 5 through 10, right? And in fact, in this case, what's the base case for this recursive function?
Base case?
Yeah.
So it sees if the element is inside the array is an array, right? So it will go through till there is no array inside the array, right?
That's the opposite of the base case, though. What's the base case? Yeah.
The length of the original array.
Nope. So what you just described was when we keep going. The base case is when we stop. So when do we stop?
Assuming when there's no element in the array.
There's no nested array in the array.
Here we, between lines 5 through 7, 8 through 10, we see this very clear if-else statement, right? In the if statement, we keep recursively calling the function. That must mean in the else statement is when we don't recursive call the function. So the else is our base case. And how do we get to the else? We get to the else when array.isArray element gives us back false. When the element is not an array, that's our base case. That's when we stop. The really cool thing, or the really kind of like interesting thing about this function is we don't. So far, when we looked at our recursive functions, we do the base case check like once, right? We say, okay, great. If array.length is 0, then we do something else, right? Or if num equals 0, we do something else, right? Here we're not base case checking it once. How many times are we checking it?
Every single time.
We're checking it the number of times for number of things are in this array, right? And so in this entire logs and array function, we go through every single element in this array, and for every single element, we run this process to figure out, do we recursively call the next function, or do we stop, right? And we do it for as many things, for as many elements as there are. So, so the way that this function works then is, when I first try to say, hey, let's logs an array, and I pass in 1, comma, the array 2, 3, on the first pass through, I do in fact look at the first element of this array, and it's going to give me back a 1, right? Because I'll say element is equal to array index is 0, which is the number 1. Is 1 an array? The answer is no. So we're in our else clause, and we console log out 1. So far so good. But obviously we're not done, right? Because guess what? Now we move on to the next element in our array. The next element in our array is the array 2, 3. And I go through this again. Element equals array index of 1, which is 2, 3. Is this element an array? And the answer is yes. So that requires us now to do logs an array, and we pass in the array 2, 3. And remember, this builds up on our call stack because we cannot finish this function until we finish this one, right? 1, 2, 3, 1, 2, 3 has not finished running yet because we haven't finished processing the 2, 3 array yet, right? So in order to process this part, we need to run that function. And when we run that function, now what's going to happen is I start a new iteration of logs an array. My array is just a length 2. The number is 2 and the number 3, right? And I go through this one more time. I equals 0. Element at index 0 is going to be 2. Is 2 an array? The answer is no. So I console log out the element, which is 2. I then move on to the next iteration of the for loop, which is going to be I equals 1, right? Element at array of 1 is going to be 3. Is 3 an array? No, it's not. So I hit the else clause. I console log out the 3. And at this point, I increment I one more time. Now I becomes 2. Is 2 less than 2 because my array has length 2? The answer is no, it's not. So my for loop is finished. And only at that point can I say I finish running my logs and array function for this 2, 3 array. And I take that off my call stack, and now I can pick up where I left off. Where I had left off with looking at the second element of this array. And so that was here. So assuming I finish line 6 now, I go through, the next increment is I++, which is going to make I equals 2. Well, is 2 less than length 2 here? And the answer is no, because I had an array of 2 things, right? The 1 and the array. I've processed 1. I've now finished processing the array. So I'm done processing this entire array. I finish my for loop now, and only at that point does my logs and array function finish. And by doing so, I've also been able to print out 1, 2, 3. So what this function kind of really has allowed us to do in this particular instance is actually let us say, I don't know how many times you need to call logs an array. So I can't use a for loop for this beforehand, right? I can't say, oh, you're only going to go 1 level deep or 2 levels deep or 10 levels deep. I would just say, hey, as long as you need to, keep calling logs an array. And eventually, the hope is, the assumption here is that at some point, this array will end. We just don't know how many levels deep it is. And honestly, we don't care, right? This function will just keep running until either the computer runs out of memory or we've reached the end of the array. Yeah?
So I got it up until you went to the array.length at the end, and you had said, when it comes back out of running its if array is array element for the array with 2, 3, you said it failed because array.length, because I wasn't less than array.length.
Yep.
You mean array 1 with inner array 2, 3, because that's only a 2?
So in both of these cases, the array.length is going to be 2, right?
Right.
And so then when we iterate through it, when we start at 0, that's the first run.
Right.
When we do the second element, that's I equals 1, right?
Right.
After I equals 1 finishes running, we then increment that 1 by another one. So we have 2.
Right.
is 2 less than 2?
Yeah.
So therefore, we're done with the for loop.
So this isn't so much what you're showing us here. This doesn't look like an alternative to for loops. It looks like you can use the for loop within your recursive.
Well, in this case, we do use a recursive function with a for loop because we're going through an array.
Yeah.
But the question is, rather the point here is like, we can't do this problem without recursion.
Right. Okay. Cool.
Right. Whereas in all the morning workshop problems, we could do it without recursion if we had to.
But it's not an either or exactly.
Oh no, it's. I mean.
Like recursion is a way of thinking about what
Exactly.
you're doing.
Yep. Exactly. So everything we're giving you is just tools, right? It's like if you hammer like a screw hard enough, maybe it'll go into, right? But it's just not the best tool for it, right? So like we're giving all these tools, and as long as you understand how to use them, like feel free to be creative. And really, like that's kind of why like this morning I did the detour to show you how the for loop, like you don't need numbers, you don't need an array or a string for it to work. The idea here is that like if you understand how these tools work fundamentally, then you can be as creative as you want to think of the solutions that you want, right? And really, like that's why people pay developers, right? It's not because we need you to do the same thing that everyone else knows how to do. It's like we need you to solve problems that maybe other people haven't solved before yet. Okay, so so that was an example of us of us using recursion to solve a problem that we really couldn't solve without recursion, right? Because otherwise, if I have an array that's 10 levels deep, if you don't have recursion, you just keep writing if statements over and over again, right? If this is an array, and then if that first element is an array, and if that element is an array, like it gets very tedious after a while, right? Because you realize you don't know how far you have to go, and so therefore iteration isn't really a practical way to solve that problem. Here's another problem that also makes use of recursion as well. So if I say, hey, if I give you an array of strings, right? Can you actually, if I give you an array of strings, are you able to join all of those strings in for me into one massive string, right? So if I give you this array of A, B, C, could you just join them up for me into one string that says A, B, C, right? And obviously, if everything was only one level deep, if it was just strings, well, we have our final string equals a blank string. We iterate through our array. Every element equals array next I, and then for every element, we'll just add it to string. At the end of the day, we return final string, right? Once again, one-dimensional array, not much complexity. But obviously, if I now say, well, geez, what if I give you an array and everything in the array is either going to be an array or a string? Now we kind of face this complexity where it's like, well, I don't know how many layers deep I need to go into, right? So it's very similar to the previous problem. The only difference here relative to the previous problem is, in the previous problems, we just cared about console logging out the element, right? And then we kind of move on. Here, we kind of see our old friend return again. And this is important now because not only do we need to know what the element is, but we need to kind of keep track of it over time, right? We can't just say, oh, I saw it, let's move on. It's like, oh, I saw it, I need to tell whoever asked for it what I saw, right? So the way that this problem is set up is we still have our kind of final string at the beginning, and we'll talk about why that this is like a perfectly fine practice to do, and why this is not a global variable, so to speak. Okay, so we have our final string. I still iterate through my array, and this is going to sound very familiar to the last problem, right? For every element in my array, I take a look at the element. I say if the element is an array, I do this. Or rather, if the element is not an array, if the element is just a string, well, I just add the element to my final string, right? And at the end of the day, I return my final string. So this is my base case. If the element is a string, I just add it to my final string and I keep going. I don't worry about it, okay? But if the element is not a string, what do I do? If the element is not a string, then what I do is I add concat else element. And notice what I'm passing in here, right? If the element is an array, then I'm passing in the inner array to concat else, right? I'm going to count on this to give me back a string. And what that string represents is going to be all the letters inside that inner array joined together as a string. And once I get a string back, I can then add that to final string as well. So let's kind of be more granular in terms of how this works, right? Well, initially, if I feed in a concat else of an array with A, comma, second element, which is an array of BC. Well, for the first element, when I go through it, I'll create my final string array, and then I'll say, great, the first element, is it an array or not? And it's just a letter A, so it's not an array. So therefore, my final string so far is going to be the letter A after I go through the first element. When I go through the second element, it's going to say, all right, great, let's add, is it an array? Yes, it is. Great, let's add concat else the array b comma c to it, right? And so now we come here, and at this point, in order to finish this line, we actually need to call this function and figure out what it gives us. So then we call concat else with b comma c. When we call concat else with this array b comma c, we run this function from the very beginning, which means that we also run line 2 again, right? So this means, and this is kind of a misnomer if you're just kind of thinking about this for the first time, right? This means that there are multiple versions of final string floating around, right? Like this array has its own version of final string, and this array has its own version of final string. So really, this final string, it does not mean, oh, here's like the global final string. This is a final answer for everybody. And this kind of speaks to your question earlier about adding numbers, right? What this variable just says is, hey, this is a final string for everything that I've been given, right? This is a final, so the final string for this guy is going to be the final string for everything in the array that was passed into me. The final string for this function is going to be the final string for everything that was given to me, right? And so then if we look in that context, and final string starts off as blank, we go through this array. The first element is b, it's not an array, so we add b to final string. And now the final string for this function is just going to be b. And then when we go through the second element, it will just be c. And at that point, we're done with this array, right? Final string is just a string bc. And then we return final string. If we return final string there, we now see that, great, concat else b comma c is just bc. So I can finally return bc back to the final string for this input. And now I can add a to the bc, and I get back abc. Right? So at every juncture, you really want to be very clear in your mind, like what's being passed back and forth. Right? Remember, the point of recursion is not you're solving everyone's problems all at once. The point of recursion is you solve the micro problem, the small portion of the problem that you've been given. Right? As far as BC is concerned, it doesn't care what came before it, right? It doesn't even care if there's arrays inside of it. All it cares about is, hey, look, I'm going to give you a string of everything that's been passed to me. If there's an array inside of me, I'll call another concat else for them to figure it out. Once they give me back a response, I'm going to add to my answer, right? So final string is always going to give you a partial answer until you get to the very last iteration, in which this partial happens to be the entire input. So it is your final answer. Does that make sense? Okay. Nested objects are very, very similar to nested arrays too. To nested arrays. Here we have a function that honestly isn't super different than what we saw earlier, right? So if I have an object here that's just with two keys A and B and the values of 10 and 20 respectively, if I want to add up every single value, then I just do let key and for in loop, let key in obj. The value is going to be obj index at key, and we just add the value to sum, right? So in a one-dimensional object with only numbers as values, this is how we would add up every number that's a value in the object, right? But if we did have a heavily nested object, something like that, well then, once again, this code looks kind of very, very similar to what we've seen previously, right? In that we still want to do the var let key in object, and value is still going to be obj index key, but we now do a check. If the type of value is not an object, well, we just add the value to the sum like we do for all of our other problems. But on the other hand, if the type of the value is an object, well then we do sum vals, right? And so when we do that in this case for this problem, what we're really saying is, well, at my first key, which is A, the value is 1 and is clearly just a number, so I'm just going to add it to my total. So my total is 1. And then I'm trying to add, and then for my second value, it's this massive object here. Well, for that massive object, if that type of value is an object, and it is, I need to add to it some vals with the object, right? Well, how do I calculate what some vals of the object is? I pass it in, I call this function again. I create a new variable called sum on line 2 that only cares about what the sum of everything inside here is. and I go through this process over and over again. And so the thing here that hopefully you'll realize very quickly that at every iteration, we're not trying to go through to the very end of our nesting. We're just unpacking one level of nesting, and if there's more nesting, we give it to the next guy or to the next iteration of the function to work on, right? So every time we call this function, we're only focused on getting rid of one level of nesting. So by the time we get to the very end of this, we get back to an object in which the values are only numbers. It's 2 and 3. So when we add them up, we get 5. And then we can start passing this back and forth to us, passing this back to whoever called it, right? So we're going to add all these sums together, and by the end of it, we get 6, right? So every time this recursive function runs, all we're really doing is we're kind of going through one additional layer of depth in the object. We don't know how many layers of depth there are, and we don't care because guess what? Our function is designed so that as long as there's more depth, it will just keep calling and keep calling and keep calling until it finishes. This is in contrast to a for loop, which is for a for loop kind of beforehand. You tell it, hey, you want to go 3 levels deep. You want to go 5 levels deep. Here, we go as deep as we need to.
So I'm a little bit confused about how you write it here. So value, object, parentheses, key, that means that, that's how you were able to see if the value was a number, right? Like basically if it's the object, because the keys are letters and the objects are numbers. So that's how you knew you could add those things?
The object is an object, the key is a string, and the value is a number associated with that string.
Oh, okay. Perfect. Okay.
Yep. Cool. All right. So that was pretty much it, right? So a pretty quick lesson, so to speak, but also something that's it's definitely an application of recursion. But like I said, I don't think you'll be asked to do too much of this in the interview. Although obviously, if you understand this, then you're definitely kind of at a level with recursion that you should feel very confident in going into the assessment. Any questions? Yes, right? Or Brandon?
Did you say? So you were saying we use recursion for certain type of problems versus certain other types we use it for, and if the problems aren't that dense. But when you get to when